Okay everyone, we are going to be looking at plans and elevations. It's going to be a brief introduction. There's a couple of videos in this playlist. This is a very straightforward topic. You just need to be able to visualize shapes from different angles. So I just want to start off with an interesting activity where you have to guess what the shape is. So what 3D shape do you think is making the shadow on the screen? Have a think about all four of these and I'll show you what the answers are. So in the first case, you can probably figure it out, it's going to be some type of cube, cuboid. Second one, if it's a 3D shape, it's going to be a ball, perhaps. The third one could be a pyramid or a prism. And the last one is a bit of a trick question. You would assume it might be a cuboid, but this is actually a cylinder. So a shadow a cylinder makes would just be a rectangle. So just something to be aware of with these types of questions. Here's a few other interesting ones. Slowly, this is going to show you more shadows from different angles, and each time a new shadow is revealed, you might decide to change what shape this is. So what shape do you think this is? If I give you another shadow, what shape do you think it is now? I'll give you another one. What shape could that be? So using that, I think you can be secure it's generally likely to be a cuboid. We do another example here. What shape could this be? Here's another shadow looking like a cuboid. What could it be? So in this case, you can see it is going to be a cylinder. Okay, and then these are the three shadows on the side. Right, another, I think this will be the last example. You've got a square base, square shadow, triangular side shadow, and then another triangle on the side. This is likely to be, because it's a 3D shape, it's going to be a pyramid, a square base pyramid. Okay, so the topic is plans and elevations, and it's very straightforward because basically we're looking at shapes and how we can draw them from different angles. Plans has a specific meaning in maths, is an object for looking at it from a bird's eye view, so from above. And so here's an example of like a building or an object where the plan view would be from above. The plan view would look like this, because we can see there's a rectangle and there's this little kind of slope on the side as well. Now that slope, in this case, we just draw it from above. It's just going to look like a rectangle. We don't need to shade it in to show that there's like a slope on there. It's just a slope on the roof. And then the elevation is a view from the side. Now, obviously, there's four sides to this shape. So we can usually call them front elevations or side elevations, and that's always very clear in the question. But in this case, we just call them A, B, and C. So the elevations in this case would look like this. So elevation A is from here. It's just going to be, you can see that face and then this face here. And then that will give you the first elevation. The elevation B from here, you'd be able to see the square side and then that little triangle. The fact that it's recessed and it's further back, you can't really show that in an elevation diagram. And then for elevation C, it's from the other side. So in terms of practical uses of this, you can imagine engineering when you're designing products, including phones, shoes, water bottles, TV screens, anything would require a lot of specific planning. In science and medicine, if you're doing scans of 3D objects, they would be represented in 2D printouts. So examples are brain scans. Architecture we've talked about as well, and in 3D game design, and then things like astronomy as well, where you're showing three-dimensional surfaces in 2D. Another practical example is aeroplanes. So you can see you might use these types of drawings when you're designing an aeroplane manufacturing. So you can see the plan views from above, and then you've got a side elevation, front elevation. All of these give you a lot of specific detail. So examples of houses. If you in real estate, estate agents, here's an example of my house and the floor plan, and all the, like when you buy a house, you're told about all the different the amount of floor space you get when you look at it from above. Okay, so here is an example of an actual practical question. It says, the question would ask you to draw a plan view, front view, and a side view. Now, the plan view is always going to be from above, so that may not be labeled. However, the front and the side, typically they will label which one is the front and which one is the side. So in this case, you might be given a grid and then you're asked to draw the front view. So in the front view here, we can see it's going to be this thing here. And I can see it's just a 1x3 rectangle. So I just draw that on the grid. I don't need to color it in, don't need to shade it in, don't need to separate each of these. It's just that is your answer. You can also draw this anywhere on the grid. So I could have done it on the side down here. Generally in the middle is more sensible. You're not going to get such simple shapes as this, but you know, in this case I've shaded it in on the right. So the other view is a side view. Now you can see just by looking at the diagram, it's going to be 2 squares along, 3 squares high. So it's a 2x3 rectangle. It's just going to look like that. So you can draw that anywhere on the grid. And then the plan view from above is just going to be a 1x2. Might look like that. Now, the orientation doesn't matter. For example, the plan view, if I did it like this, it would still be correct. It could be sideways or not, doesn't really matter. The front elevation, doing it like this wouldn't be sensible because it's not a front view. The plan view, however, because you can rotate it, doesn't really matter. So here's an example for you to try in your head, or you can sketch this out, have a go, and then I'll show you the answers. Okay, here are the answers. Now, sometimes you may get questions where, you will get questions where you've got different elevation, different heights within the same shape. So just a recap on some language. These bits here, the corners, are called vertices. The straight lines are called edges. And then the bits on the side and the top and the front are faces. Okay, so if you're asked to draw this, the front elevation would just be this L shape here. And that's fine, there's your front elevation. The side elevation is a bit different here, because imagine if you were standing here, you could see the purple face there, but you would also see this purple face here. Now, drawing that, the fact that this purple space is pushed back is quite tricky, so you don't have to do that. You're just going to draw the actual shape itself, and then there's the lowest rectangle. That's basically it. It's just going to be 2 rectangles. The way you show that there is some type of difference in the depth of the shape is just that line in the middle. So the answer would look like this. I did mine 1 square too wide. It should actually be 2 squares along. So it's 2. That's basically it. That line in the middle is important. You don't need to clarify which bit is recessed, which bit is closer, doesn't matter. And then the plan view from above, again, it's the same idea. You can see the 2 blue rectangles. So you're just going to draw 2 rectangles, 1x2, 1x2. I'm not doing this very neat because I'm using a computer here, but you can see that's basically what your answer is going to look like. So here's another example of a question. If you have a go with this, pause the video and then we'll continue. Okay, so front elevation would look like this. Don't forget that this line here is important, separating. And then side elevation and plan view. Okay, another bonus question. Have a go with this. Front view, front elevation, side elevation, and plan view. Okay, so front, you can see we're going to have a 4x1 rectangle. We're going to see these as well, these towers on the side. So our front elevation is going to look like that. The side elevation, we are going to see this 4x1 or 1x4, and then there's a 2x3 just on the right hand side, so that would look like that. And then for the plan view, what we'd see from above are these two rectangles and then this kind of T shape, and that would look like this. Okay, I hope that was useful. Make sure you watch the next video so you're ready for the worksheet. Smash the like button.
Number 30. Do you know sine 2x over x? Max. Okay, so sine x over x as x approaches 0 is